Okay, so as in the last video, we discussed about principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. We initially discussed that principal quantum number give us information about the size of an atom, which means they tell us about the shells, right? K, L, M, N. Then we talked about azimuthal quantum number, and azimuthal quantum number were nothing but they gave us information about the subshells, right? S, P, D, F, these are the subshells, right? And additionally, they tell us about the shape of the atom, all right, in which shape there would be. So S represents the spherical, P represents the dumbbell, D represents the double dumbbell, and S, not S, however, F represents the 8 folds, right? Afterwards, we discussed about magnetic quantum number, and they were nothing but they tell us about the orientations, right? Orientations which are made in the subshells, which means you can take as shell is a superset, all right? Azimuthal quantum number are the subset of principal quantum number, and then magnetic quantum number are the subset of azimuthal quantum number. I'm going to clear this theory. Wait. Magnetic quantum number, they give us information about the orientations, all right, how many orientations there would be. In S there is one orientation, in P there are three orientations, which means there are three orbitals, in D there are five orbitals, in F there are seven orbitals. Then we talked about, last but not the least, spin quantum number, and spin quantum number were nothing but they gave us information about the spinning of the electron, how the electron would be spinning either in the clockwise movement or in the anti-clockwise movement. So in today's video, I'm just going to clear the theory of this superset, subset. As initially I mentioned, principal quantum number is the superset, then azimuthal quantum number is the subset of principal quantum number, then magnetic quantum number are the subset of azimuthal quantum number. I'm going to clear this theory now, and afterwards I'm going to explain you guys the Pauli's exclusion principle, which plays a very important role in electronic configuration. All right, so let's make the set diagram here, not set however Venn diagram, right? Because I want to represent here the sets. So here we have Venn diagram of quantum numbers. This is the best example to understand the quantum numbers. Quantum numbers. Alright. So initially we discussed about principal quantum number. That is basically what it is, the superset. Alright. So this is basically superset. Alright. This is the superset, which is basically what it is, nothing but it is principal Q number, which means quantum number, which is denoted with, of course, the letter N, right? So we have now discussed azimuthal quantum number are basically the subset of principal quantum number, all right, which means this should be inside it, all right, and this is nothing but it is azimuthal quantum number. Azimuthal quantum number, which is denoted with letter L. Alright, then we have magnetic quantum number, which are the subset of azimuthal quantum number. So this should be inside it, and this is nothing but it is what? It is magnetic quantum number. magnetic quantum number, alright, which is denoted with letter M. So wait, let me highlight this initially. Alright, this is perfect with yellow, this M. Alright, now you can see a Venn diagram here. Alright, principal quantum number is the superset, while azimuthal quantum number are the subset of principal quantum number, and magnetic quantum number are the subset of azimuthal quantum number. So I should write this here as well. Principal quantum number, or I should only write here n. That would be more easier to write, right? So here I am writing with this pink one. So n is greater than L and L is greater than M. And we know that n represents principal quantum number, L represents azimuthal quantum number, M represents magnetic quantum number. So this represents principal quantum number. Alright, this L represents azimuthal quantum number, and then this M represents magnetic quantum number, alright. Now we have basically understood that theory, what that theory actually explained us, that principal quantum number is the superset, while azimuthal quantum number are the subset of principal quantum number, and magnetic quantum number are basically the subset of azimuthal quantum number. Alright, now we are going to discuss the last topic of this quantum number series. Then in next video we're gonna start discussing about the electronic configuration. Alright, so this is our very last video of the quantum numbers. Now we are going to discuss the Pauli's exclusion principle, which plays very much important role in this quantum number series. Alright, so now we are going to discuss what? Pauli's exclusion principle. What it basically gave us information about, let's see here. Alright, so Pauli's exclusion principle says that there would be no two electrons which will gonna possess these four same quantum numbers. So what did he say? No two quantum numbers. So what did it say basically? No two electrons would gonna possess would gonna possess same set of quantum numbers, set of four quantum numbers, which means it can have three same set of quantum numbers, however not same four set of quantum number. Let's see an example here. Now see, if shell K1, which means 0, 0. Now 2, you know what, there are same quantum numbers. Azimuthal quantum number is also 0, magnetic quantum number is also 0. However, their spinning would be different. One electron would be spinning clockwisely and another would be spinning anti-clockwisely, which means two electrons can have three set of quantum number same, however their last spin quantum number would always be different. Since if there would be two electrons, one electron would gonna be spinning clockwise and another electron would be spinning anti-clockwise. So there would be three same, there can be ability, or then there can be a probability of an electron, of two electrons having same set of three quantum numbers, however not fourth one, because their spinning would always be different. One would be in clockwise, one would be in anti-clockwise. So this is what Pauli's exclusion principle told us about. In the next video we're going to start our electronic configuration, which is the very last subtopic of our this chapter.